So hello Aya, today we will start a new topic which is
Prealgebra.
we will start the series for Prealgebra, but the first topic we'll start today is gonna be something called Properties of Arithmetics. Okay, so that's what the first topic will start. Now, what is arithmetic? So arithmetic is basically, it's the knowledge of addition,
Subtraction, multiplication, division.
Yeah, subtraction, multiplication, and division. Okay. So yeah, that's.
So you need to know them well, not just like you can do.
Yeah,
them.
means you should be comfortable with them. You should. Now the only thing which is really hard with arithmetic is basically you need to you need to do those to solve those problems, right? Word problems. So that is the only thing which is a little hard. Okay. Now the second topic, which because this series is all about pre-algebra. So what is pre-algebra? Now.
Oh, pre-algebra is the bridge between arithmetic and algebra.
Yeah, so that's what we learned, is that we actually want to learn algebra, but before learning algebra, we want to kind of learn a bunch of other topics. And this is what this entire series is going to be about. It's basically the bridge,
like the book about.
the bridge between arithmetic and algebra. Okay. So now the question is, what is algebra? So I think that's not very important to kind of understand as of now, but the idea with algebra is that algebra allows you to kind of generalize a lot of things, and using those generalization you can solve a lot of difficult problems. Now that's very hard for you to understand, right? But we're gonna think about that later. Now, what is the goal of this chapter, the properties of arithmetic? So what is the goal of this chapter? So the goal of this chapter is that by the end of this chapter you should be able to answer a bunch of questions, right? So the goal of this chapter is that you should be able to solve following problems, like something like that. The first one is that, so what should the value of this be?
5 into
minus 5 into minus 7. So that is minus 35. So you should be able to understand why this is the answer and not minus 35. Okay, so that's kind of what the goal is, one of the goals. So the second goal is that
just cuts the minus off, I think.
Yeah, so why that is the correct answer, and that's the goal. Now, so the second goal of this chapter is not necessarily, I think this is some of the examples, right? But you should, by the end of this chapter, you should be able to answer these questions. So now if you look at this one, you will think that, oh, it will take me so much time to solve this question, right?
Yeah, you will have to first do this.
Yeah, but the goal of this chapter is that you should be able to do this question in your head, or even with one of few steps you can do it very quickly. Okay, that's the goal of the chapter. And the answer is, it's not hard. Once you understand the properties of arithmetic, you can solve it very quickly. So that is the thing. Once you understand the properties, you will be able to solve it very quickly and easily, and you will say it's a very easy question. Okay. The third problem is 8, and you can
eraser.
Yeah, eraser, and go back to the pen. So again, 8 divided by 1 by 6 is 56. So this you should be able to understand and
tell. Wait, 8 into 7 is
56, right?
56. Yeah. And then the 1, I guess we don't even do anything.
So 4 into 10 into 49. 2 into 5 into 7. And again, this is, you will think like, oh, it will take so much time to divide, do all these things, but you should be able to do it very quickly.
Wait, so 4 into...
Yeah. So how are we gonna do this kind of question? That is kind of the goal, and you do them fast, right? That's kind of the goal of this chapter. Okay. So now that we are clear with that goal, So one of the first thing we kind of need to remember is that what we have studied earlier, I think, and earlier also, is that
a number line.
Yeah, we taught you something called a number line. Okay, number line. Okay, so what's a number line? So we start with 0 here, and then 1, 2, 3, this side,
That's
4,
positive.
and you keep going it. So everything right of 0 is
Positive.
and you keep going on forever.
Forever. Till
Similarly,
infinity.
on the other side, you
Is
go
minus.
-1, -2, -3, -4, -5, and so on. So you go on the negative side forever.
And that's negative. The left of
Yeah.
0 is negative.
So the thing is that all the numbers we will talk about, they will lie somewhere on the number line. Okay. Now, the numbers which does not have a fraction, right? This number doesn't have a fractional part. These are called integer, which you have learned in programming and everywhere, right?
Yes,
Numbers
integers.
without fraction are called integer. Okay.
All the whole numbers, all the positive and negatives are
Yeah, all of them
integers.
are like all these numbers you can see which we have printed here. They basically forms the integers, right? And another things you will note is that a lot of time you will see that when we write some series, like for example we write 1, 2, 3, 4,
5.
and then dot dot dot. So we'll write 3 dots. What does mean? That this series is going forever like this in the same pattern forever, right? So these are called the 3 ellipses, the 3 dot symbol, and this is also called ellipsis. Ellipsis. ELIPSIS. Okay, so this is called ellipsis. So it's very useful. So remember the name of the thing.
That means it goes forever in that direction.
Yeah, means what, like you can basically they are saying that you can keep continuing using the same pattern. I don't want to write all of them.
Oh,
okay.
Like if it's going 3, 6, 9,
You
dot
can use
dot
it.
dot.
Yeah.
You have to skip counting like 3.
Yeah.
Oh, okay.
Okay. So the ellipsis is used for telling that I don't want to write anymore. I just want to do dot dot dot, and you can
And
go
if there's
figure out.
a number called 9 over here, it goes dot 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 till 9.
Yeah. Sometime also, right? For example, remember there are some other series like if for example let's say there is some series like 1, 2, 3, and I say dot dot dot, and then I will write, let's say 10, 11, and then again I say dot dot dot, and then I might say 19, 20, right? So I can also use something like this to tell that
It ends at
yeah,
20.
like you can use it multiple time to tell, okay, these are the important points here, right? So you can use it multiple places to use these 3 dots. Okay. So now that being said, so another thing to remember is that so we already know what's a negative number.
Yeah.
So anything right on the left of 0 is a negative number. Positive number, anything on the right of 0 is positive number. So 0 is neither positive nor negative. So that's the important thing to remember. 0 is neither positive nor negative. Okay.
It's a 0.
It's a 0, so it doesn't have. Now, what is a non-negative numbers? What is a non-negative number?
0 is the only integer that is not
So
positive
what will
negative.
we call non-negative number? So non-negative number is non these, right? So 0, 1, 2, 3, and so on, right?
Yes.
So negative numbers, basically you remove all the negative numbers and everything else is a positive number. So it's a 0, 1, 2, 3, 4, all of them are non-negative
Not
numbers.
positive.
And what is non-positive number?
Are these ones?
What should be that will be? So that will be again 0, -1, -2, -3, and so on. Okay, so 0 is included in both the cases.
Yes.
Now, yeah. So now, once we are done with this, we start with our first topic, which is gonna be addition. Okay.
Where do we plus it? Oh, I think this.
Okay, I think the mouse can do the mouse. Okay. Oh. So the next topic which we want to discuss is addition. Addition. So you already know about addition. So that's what not we want to discuss. We want to only understand certain properties of addition.
Oh, I know addition has two properties.
Like maybe have multiple properties, but right now we are only like we're going to discuss some of the properties. Okay, they might have multiple properties. So one of the questions is that, let's say, so one of the thought process. Let's say explain why 2 plus 3 is same as 3 plus 2. So that's the thought. Okay, why?
Oh, maybe do like.
So one of the things to understand this point is that, let's say if you want to write this 2. So let's make a figure and this has 2 boxes and two things, and there are two things in it, and there are 2 boxes, right? 2 elements, right? And the second one is
3 on
three
the bottom.
things. So you made 3 things on the bottom. Okay. So this is, and this whole thing has 5 items now. So the first element is here 2, and the second element is here 3. Okay. Now what you do is you can write for the same thing for similarly for the other one.
2.
So 3 plus 2. So 3 plus 2 look like 1, 2, 3, and this below one, the second item will look like 2.
Oh, it's flipping.
So yeah, so the idea is there now. It's not flipping, it's upside down, right? So the first one, both the images are basically upside down of each other. So now this means that both images are
upside down.
Yeah, or figures are figures, or basically figures are upside. So the other both the other figure is basically upside down. Okay. So the right side is basically upside down version of
The
left side. Okay. So if that is the case, the point is that the number of element will be same. This means
it's communicating.
now this means the elements numbers are same, right?
Yeah.
Right. So this means that 2 plus 3 is same as 3 plus 2. Now the idea is that if any other numbers are there, let's say we have 5 plus 7 or 8 plus 10 or any other number, right?
This will apply.
This will still apply, right? So it doesn't matter what two number we try, this is gonna apply.
Okay, and this
So
is called.
the way we can do is that we can say that, let's say we have A and then we have B, right? And we say that A plus B is same as B plus A, where we are saying A and B can be
Same.
any number.
Oh, any
number, right? So that is the thing we can kind of intuitively say that now. That idea is that if we have A plus B is A plus B is gonna be equal to B plus A always for any A plus B where they are a number, right?
Right.
So that's kind
because
of what
they're just flipping. And what's the difference if they're just flipping? They're both the same. That no value is changing.
So the number of element will be the same. So that's kind of what the logic here is for addition.
And this one.
So this is not a formal proof. This is not a formal proof.
What does that mean?
We will learn what formal proofs are in maths later. But this is not a formal proof, but kind of gives you the intuition. But kind of gives you intuition why the above might be true. Why the above might be true. Okay, so that's what we want to understand. Now this property, this thing where A plus B is B plus A,
it's called
commutative. Okay, this is called commutative. So the above property is called commutative. So what this means is the addition is commutative. What this means is the addition is commutative. Now why this is important, we're going to learn later, like why this is important. So that's the first thing we can do. Okay.
2.
Now the second property which we are going to learn, or we'll take another example basically, again we'll example. So explain why 2 plus 3 plus 4 is equal to 2 plus 3 plus 4. Okay. Now again what we'll do is we'll try to make some figure for understanding this, right?
So
let's make the 2 for the first one, and we'll make the 3 for the second one, and the 4 for the last one. Okay.
And then make the lines.
Make a line here and make a line here.
And then a line here.
So one thing what a line here. Okay. So the first one is 2 element, the second one is 3 element, for the fourth one. So now we'll shade this. So just to tell,
the shaded part is what we do first.
The shaded part is what we do first. Similarly, we go the other side. Again, we have 2 things, and we have 3 things, and then we have 4 things. Right. Okay. And the shaded part will be different this time.
The shaded part is more.
Yeah. So now, now what we are doing? So what we are doing is that we will, let's say in both the images, as we said, if we have 3 numbers, like if we have 2 numbers, we know we can add them, right? But if we have 3 numbers, then we need to first define what numbers we need to add.
The bracket.
So what the question said is that 2 plus 3 has to be done first. So we just shaded that part. In the second one it says 3 plus 4 has to be done first. So we shaded that part. Now what we'll do is that we first do the addition of the shaded part first, and then we'll add it to the non-shaded part.
Yeah.
Now the question is that if we do that, is changing the count?
No, I don't
No,
think
it does not change the count again.
Because look, these two are the same thing.
Yeah, exactly.
It doesn't matter what part is shaded. You can still count them all.
No, and the point is that you don't have to count it, right? You can see the image still look exactly the same. Only the shading has changed.
Yeah.
So it is still the same, right? So again, we can kind of.
The point is the total, not the shaded part.
Yeah, we can figure out the number of element is still the same regardless of the order we add them, right? Okay. Now this kind of generalized to the other generalized to an equation which is called a plus b. C is equal to c. So okay.
Oh, the brackets are just moving this side. See?
Yeah. So
first the brackets were at the end. Now it's at the front.
Yeah. So that's what we call it, right? We basically, if we have 3 numbers, it does not matter which 2 we do first. Okay. Okay. So that's what. So the point is that commutative, what we said, we change the order. Like we reverse the order of any 2 number. Right? Yeah. We can reverse the order. But in associative, we are not reversing that. What we are saying is that what we want to group or do first.
Yeah.
So associativity is about grouping. Okay. It's about grouping. The order is still the same, right? We are not changing the a plus b plus c. The a plus b plus c. The order is still the same. But we are grouping them differently. Like which one we want to group them and together and do first.
Okay. So associative.
Yeah.
Its name is associative.
But yeah, and this property is called associative. This is also called associativity. Okay. So associativity. Okay. So this is the addition is associative in nature. Okay. Now using these two things. If you remember these 2 things, what it means is that if we are given any addition, right? Okay. And it doesn't matter how long it is, like a plus b plus c plus d plus d. Now what we can do is we can change them in, we can do it any order, right? We can reverse anything, right? We can do first anything.
Yeah.
So we can do any of those things is correct, right? Now why this might be useful? The question is that why this might be useful, right? So to give this example, I'll give you some example, right? Okay. So there we do 2 questions. So first question is, let's say we write 472 plus 219 plus 28, and it is said that we have to prove that 472 plus 28 plus 219. So which will prove that is these two are equal or not. Now one of the ways is that you could have said, oh, I can add them together this side and I can add them this together this side, and if they end up equal, then I'm correct, right?
Yeah,
but that is too slow. So that is the whole idea. We don't want to do that. Now what we learned is that if I look at these two numbers, I think it's both of them looks all the numbers look the same, right?
Yeah.
So the only thing I need to prove, the only thing I already know some of the things. So for example, I can do is 472, and if I change the order here, 28 plus 219, and then basically I'm taking the left side, right? Oh, so I should let's just erase it first. I'm gonna say I'll write some cleanly little to explain the steps. So I can first need to choose. I'm gonna choose left hand side. Okay, so I'm gonna choose left hand side, which is 472. Oops. Which is 472 plus 219 plus 28. Okay, so you say equal to. Okay, so you start with left hand side and that's equal to this much. Okay, now I say I can change 472 plus 28 plus 219. So I reverse these two only, nothing else I change. So this is, I can do this because
commutative.
Yeah, because I can write it commutative. Okay, this is very clearly. Okay, now what I can do.
Oh, then you can move the brackets this side and it'll be associative.
And then I can remove the bracket and move it this side, and this one is because associative. Okay, because of associative property of addition. Now this whole thing is same as
this one,
right hand side. So I finally started with left hand side and I reached the right hand side, which means my left hand side and right hand side both are equal. And the question is done. Okay, that's how you. That
was in like 5 seconds.
Yeah, that's a step of proving something, right? You start with one side and you prove that that's equal to the other side, and you're done. Now, just going to the second part of the problem, the same question. Okay, but if we want to actually solve it, we can also solve it a little faster. What are the things we can do? We can look at these two numbers, and we can think that okay, these two numbers probably will add to 500. So again, we don't have to worry too much about it because we can do it any order. All of them are addition. So right? We can even remove the bracket. We already know.
It is 500 actually.
So we can directly do 272, 28, and we can do that together, and we can do 219. This one, and this becomes 500, and this becomes 219, and this becomes
719.
So I can do it very fast. So knowing this, that sometimes reordering things, it makes things faster.
And faster.
So that concludes addition. So first topic is addition, and that concludes the addition topic. Okay, the next topic we're gonna study is the properties of
multiplication in our next video, right?
Yeah, multiplication. Oh, we continue that one. We will finish multiplication and then we'll stop. Okay. So we will talk about multiplication. Okay, so multiplication. Again, multiplication. So we will just understand the properties of multiplication. So like last time, we need to do this. Explain why 2 into 3 is equal to 3 into 2. Okay. So what is the intuition behind it? So one of the things we kind of know.
We have to make a box that's 6.
So one of the things we know again we know is that multiplication can be treated as a kind of a 2D grid, where this side is the number of rows, right? So the number of rows is 3. Okay. We kind of did it wrong. We want to kind of do it 2 into 3, right? So we kind of do it wrong. So there is only two rows.
Oh, okay.
We want to do it only 2 rows. So we'll say this is. So yeah, the number of rows is 2, and the number of columns is 3. Okay. So this is what 2 into 3 means, right?
Yeah.
Which also means that I want to add 2 3 times. So I want to add 2 3 times, or I want to, and again I'm going to look at the other ones. Okay. So the other one basically look like again. So you have 3 rows, and you have, so rows is equal to 3, and then column is equal to 2. Okay. Now if you look at,
it's the opposite.
No, so this image basically, this both figures they are basically rotated by 90 degree. So the image is basically rotated by 90 degree. Okay, so 90 degree. So again, rotation does not means the number have number have changed. So that still the number of element are same.
That's
right?
still commutative.
That means that this is both sides will be number of elements should be equal. Okay.
Yeah.
Now we can generalize this again, same as our last time, that we can say A into B is equal to B into A for all A, B, such that A and B are number, such that A and B are numbers. Okay, so we can say that for sure. Okay, now there's another thing, one of the advantage of having this knowledge, right? Remember, we spend a lot of time trying to remember tables, right?
Yeah.
So for example, we want to learn 9 into 8, right? So what is 9 into 8? 72. But if you know now what is 9 into 8 is, you don't have to worry about remembering 8 into 9, because if you know 1, you can just say it is also gonna be 72. So this means you have to memorize the table less. Okay, you don't have to memorize everything.
Yeah, like if there's 5 into if there's 7 into 5 is harder than the 5 table, so you can reverse it and
exactly. The best example is that only. Okay, so you got one example. Okay, now there is the second part, which we did last time, is gonna be
this is commutative.
This is again, so basically it is commutative property. So commutative property hold true for multiplication also. Okay, so addition is commutative, multiplication is commutative. And now the second problem again we're gonna discuss is 2 into 3 into 4 is equal to 2 into 3 cross 4. So now the question is that is both of them are same, right? So in this case,
looks same to me.
So in this case again we have to first do a 2 into 3. 2 into 3. But once we do 2 into 3, each of these boxes should have also 4 things.
Because we're multiplying it.
Yeah, we have 4 things. Okay. Now for the other one, we have to do 3 into 4. 1, 2, 3, 4. And each of should have 2 of them. Okay. So now if you look at these two images, if you count them, what you'll find is that the number of elements are the same.
Yeah.
Okay. So now for example, it has 1, 2, 3, 4, 5, 6 boxes with 4 stuff. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 blocks with 2 stuff. Or you can kind of say, you can group them 2 at a time. You can group 2 at a time. Right. So you have 4 in each verse, right? 2 at a time.
Oh, and there should be 6
of them.
Parts.
And you basically kind of get it, both of them are equal.
Yeah.
But there is one issue, like in all the other images we were able to look at the figure and tell them that they will be kind of always be true. Right? But this one we cannot say that anymore. This one does not say
hard.
that. Yeah, we cannot see any of those patterns here.
Yeah.
So the point is that we cannot intuitively say this time that it is gonna be always true or not. Okay, we cannot say that.
You didn't even prove this.
Yeah,
one.
No, we did not prove any of the other ones.
Yeah.
But we can kind of tell intuitively.
Like you did. This is not a formal proof.
Yeah, it's not a formal proof. But there is no intuition behind now with this one. At least for this time it was same. So to prove that, like this thing, A into B into C is equal to A into B into C. This one we don't have any formal proof, or intuition wise also we cannot prove it right now.
Right.
But this is valid. This is also true. For now we assume that this is true. You're gonna learn it eventually someday how this is true. But for now you assume that this is also true. Which means that multiplication is associative. Okay, is associative.
Oh, so it's like addition.
But we do not have an intuition also behind it this time. Okay,
so
so sometimes
addition we did have.
Sometimes we don't have intuition behind it. Okay, but this basically means that we have kind of we have talked about the basic properties for addition and multiplication, right? Now, what is the advantage of this? So again, we can solve some of the question easily using this technique, right? These things. So for example, if you want to solve 25 into 125 into 4 into 6 into 8. So now you might think it will take so much time to solve it.
No, it won't. 25 into 4 is 100.
So again, because you know the multiplication is both associative and commutative, we can always change the order any way we want to. So we can make it 25 into 4 first.
Brackets.
And then we can do 125 into 8 first.
Wait,
and then
no,
we can
6?
do 6.
Oh, okay.
So this one becomes 100.
1,000.
This becomes 1,000. And this becomes 6. So this becomes 6.
6 with 5 zeros.
5 zeros. Okay. So this was
easy.
So if we know the properties, we can quickly solve it. Okay. Yeah. So now there is some of the other properties which you kind of know. Okay. Which is kind of you know. So for example, y 2 into 1 is equal to 2. So why do you think that is the case? What is the intuition behind it?
It's because there's nothing, there's no columns and there's only a row.
So there are a few ways of thinking about it. So one is that we have again row is equal to 1. Sorry, row is equal to 2 and the column is equal to 1. Right? And you can see how many elements we get? We get only 2 elements. So that is the correct, right? What is the other way? So we already know 2 cross 1 is 2. This can also be written as 1 cross 2. So 1 cross 2 is what? You add 1 plus 1. 1 plus 1 is again 2. Right? So you reverse it and you can kind of again say that 1 plus 1 is also 2. Right? But that's one proof, right? This means that this is the main one, right? Okay, that you have one column only and you have number of rows. Now this will mean we can generalize this to another thing which is called 1 cross A is always going to be A for all
cases.
A where A is a number.
O.
Where A is a
number.
A is a number, okay? Or is it A is a number, okay?
Oh, or for all cases means when A is a boolean or a
we don't know about those. We are only talking about when A is a number.
Yeah, but I'm just saying if we write for all cases, that means it like A is like not a number.
We need to kind of tell what A is gonna be. A is all the numbers for now. That's all we kind of know. That's why already 8.
All the integers probably.
No, all the numbers it will work.
It will work with fractions.
Fraction also will work. Okay, all the numbers. So now that we are done with this also, and another question will be, what is the question is that if we do explain why 2 cross 0 is 0. Explain why 2 into 0 is 0. So
because there's no column. How am I supposed to?
Yeah, but there is another kind of way to prove it. Is that, let's say you start with some number. Let's say 5 into 3. 5 into 3 is 15. 5 into 2 is gonna be 10. 5 into 1 is gonna be 5. And then 5 into 0 should be 0 because we are reducing 5 at a time, right?
Oh, we always reduce this number.
Yeah. So that's how another proof could be, that we are always reducing 5 into that. You look at any table, that's how kind of it going, right? So it has to be 0, right?
Yeah.
It has to be 0. So one of the proof could be this one.
So
okay.
A
so similarly, this will generalize to
A
into 0 is 0
for all numbers.
For all number. Now the only thing, for all number which are, I will say, non-zero, all non-zero number. I do not know what 0 cross 0 will mean. That I do not know. I do not know. I will say as of now, I do not know. What I know is that for all, non-zero numbers, it will work. But I do not know what 0 into 0 is. Okay. So I do not know. But you can say that right now. We don't know right now.
Right.
How do you put 0 into 0 is 0? I do not know for now. But we know for sure.
Like you can draw.
No, that's not how the math works. Okay. So we're gonna keep that for now. Okay. So I think before we so now there is another thing we kind of forgotten. Earlier we should have discussed that with while we are at 0. So what is 2 plus 0 is gonna be? Is 2. So this will generalize to the idea that A plus 0 is A. Again for all A, where A is a number.
I know one word for fractions too.
A number. So this one is pretty simple, right? You start with 2 element.
Yeah.
And then the second row is gonna be
0.
Empty, right? Because 0 means empty. The first is you have 2 items. Okay, 2 items. So if you sum them, what you get?
2.
You get 2 items only, right? So that's mean that 2 plus 0 is gonna be
Everything
2.
with empty will be itself.
Nothing. Empty is nothing.
No, if there's a number up here, it will be itself only.
Yeah. So there is only 2 items. So empty is mean nothing. So that's only total is 2 only. So that's one thing. Now we are gonna go and we're gonna discuss one of our. Okay, we have 2 more topics actually to discuss now. Okay.
What? We're not ending the video yet?
No, we have 2 more. Now, no. The reason we are discussing 2 more topic is that you understand addition.
Yeah.
You understand multiplication property. But what about the together? So there have to have some property which is about when you talk about them together. Right? So we're going to talk about the together stuff now. Okay.
Oh.
So that's why I'm saying you need to understand, like, they are not like mathematics is not going to be like all the equations should not be about like only addition, right? Or all of them will not be about multiplication.
Oh yeah.
There will be things where there will be both of them.
And how and all word problems. Yes.
Yeah. So how can you think about them? So those questions we're going to discuss now. So let's again first what we have to understand this, we're going to compute some of the stuff. Okay, we're going to compute some things we discuss stuff. So one is 5 plus 6 into 7. Okay. So if we want to calculate this, so and the other side we'll compute 5 plus 6 into 7. So what this will look like?
77.
This is going to be 11 into 7 and this is going to become 77. And this is going to be 5 plus
42.
47. Okay. So
addition and
so what we learned that so what we learned is that 5 plus 6 into 7 is not equal to, this is sign for not equal to sign is not equal to 5 plus 6 into 7. So what we are seeing that in both of the equation, what is changing? The order where we are putting the parenthesis, what we want to do first. Right? So if we write 5 plus 6 into 7, if we write like something like this, so we need to decide where the parenthesis will go. But depending upon where the parenthesis will go, the answer will change. So the question comes is that the how do we solve this question? So the order of the stuff matter now, and to kind of, and there are certain rules about it, and you already know those rules. Those are called we like in India we call them BODMAS, right? And the rules are basically what are called. So you have to evaluate the parenthesis first.
So
the rules are evaluate
parenthesis
first. Okay. The second rule is
power.
Yeah, you evaluate power.
And log.
We do not know what power is as of now, but we're going to learn eventually. Then what you want to do is evaluate, multiply and divide. Evaluate, multiply and divide. And the last one is going to be evaluate, addition and subtraction. Okay. Another thing we want to do is we want to do multiplication and division by left to right.
And power is by right to left.
Yeah, you already know that, so it's fine. Yeah. So this one is also left to right. Okay.
Wait,
does it matter whether we do left for right or right to left? It doesn't matter. In these two it will not matter. Well, in power it will matter.
Oh, in power it will?
Yeah, it will matter. Okay. So in this one it doesn't matter, right? Because if let's say I want to add 2 plus 3 plus 5, does it matter? Will I do for 2 plus?
Commutative.
Yeah, it doesn't matter in this one. Okay.
And power, I don't think it's commutative or associative, right?
Yes. So yeah, exactly. Now the point is that there is subtraction is not commutative. Subtraction is not commutative. So that is the reason we might want to do left to right, because the addition and subtraction will be together. So you might have to think about that. So the rule is, that's why the rule is there, because we are
wait, how come, look, power is repeated multiplication, then how come there is no repeated division?
Repeated division?
Yeah.
Repeated division is there. That is called log. Yes.
Oh, interesting.
So, yeah.
I don't even know how to log sign.
Yeah, right now we don't know, right? That's okay. We're gonna ignore that. So let's go to the last and most important topic now. So the last topic is that. So we're gonna do the last topic, right? So you understand this now, right? That the order matters, the grouping matters. Basically, not the order. The grouping matters when you have addition and subtraction and other things together.
Yes.
Yeah. So that's why we need the rule. Now let's say we're gonna explain why 2 into 3 plus 4 is equal to 2 into 3 plus 2 into 4. So this is the last one. Okay. So what does this look like? So how does, again, you're gonna make a image, right? So this one look like this. So you make like 2 rows.
Yeah.
Okay, and then you have 3 plus 4. So the column is, you can basically make.
Wait, I know. First make
3 columns.
3. Wait.
And then this is 3, and then you make a
4.
1, 2, 3, and 4. Okay. So you have row is equal to 2,
and there should be
and
7.
there will be 3 and 4 columns. Okay. Okay.
Yes.
Right.
Wait, I know.
Now basically.
What's happening?
So now this is what the things look like, right?
I know. First you're multiplying with 3, and then you're doing 2, and then you're multiplying with 4.
With 4, right?
Yeah.
Okay. So now this one is, what does this look like? So 2 into 3.
A into
So first
B,
you need to make 2 into 3.
3.
2 into 3. And then you need to add another one, which is 2 into 4.
Oh.
1, 2, 3, 4. So basically, if you look at this to addition, right?
When you
This is kind of the same image, right? This is the same image, right?
Yeah.
It basically, you can shade it, this is one part, and you can shade it this one as other part.
In this one, it's basically just adding the rows together and then multiplying. In this one, it's multiplying this and then
and then other one, and then you're adding and joining them together.
Yeah.
So this is anyhow the joined image. You can just break it, right?
Yeah.
So this means that both the sides are kind of same, right? It's just
And
about
then-
where you're breaking it, right?
And then the formula, like the A plus
The formula is called
A plus
into
B
B plus C. This is gonna be equal to A into B plus A into C.
Or you could also do it like A.
Uh-huh.
You could find the common, and then B plus C.
Okay, so this is the
Yeah.
common form. This is the
Yeah.
common form, and this is the expanded form.
Yeah,
okay?
and you can also write it like that.
Yeah, I'm just gonna tell you that part. Okay, so this is the equation. Okay, now one of the things we people have decided that, okay, people don't like to write so many symbols, right?
Yeah.
So they kind of want to write it little shorter. So what they said is that you can write like this: A, B plus C. You can ignore the multiplication, and you can write AB plus AC. Okay.
I knew this one. I never knew that one.
Okay, so you understand when you write two terms together, AB,
It means you're multiplying.
it means it's multiplying. Okay, you don't have to even write it. So this is much clutter-free way of writing.
Okay, I'm just gonna write it like that.
Yeah.
Daddy.
Now we're gonna again do a compute, and we're gonna discuss some of the stuff. So now it writes 51 again dot 9 plus 51 dot 31. So when people realize that we are not talking about decimal, what they do is they use dot for multiplication. Okay, so sometimes there is a context. So whether it's dot for decimal or whether it's for multiplication, you kind of need to know.
Seriously,
In this question because we know we are only talking about multiplication, dot is multiplication. So again, what can we do? So what we do is basically this is this form. This is the expanded form. This is called the expanded form. And when we have an expanded form, we can take the common factor out.
Yes.
So the common factor is
51.
51. We call it the common factor. We take it out, and then what we left with 9 and 31. And 9 and 31 is gonna be equal to 40. And this is gonna be equal to 2040. Okay. So this is how you can do it quickly. Okay.
204. Ugh, so hard trying
Yeah.
to do.
So again, this form is called the expanded form. Expanded form. Okay. And when we from expanded to when we try to go to this form, we call it factoring. We call it factoring. We want to take out a common factor and we want to use that. Okay.
Okay.
So that is
Done.
all the stuff we kind of learned, and these are the properties of addition and multiplication as of now. Okay. And yeah, and you might be learning other things, other operations and their properties. And as you can see, this is very, very important and very, very useful.
In our next video, what are we